Hello, future coders. Welcome back to the channel. I hope you all are doing well. This is Chetan Kumar from iLearn Academy. Let's learn to learn and learn to earn. So, we were discussing about BCA, data structure, lab manual of second semester as per SEB syllabus. Yes. Dear students, today we are discussing about program number 7, and it is also similar to your previous program, that is single linked list. SLL, that is also one of the type of your linked list, but the difference is this is of normal, this is not a normal singly linked list, it is of ordered singly linked list. Okay, ordered means the sorted one, the arranged one, the aligned one. So whatever the elements we will insert, okay, and that can be of any order, but while it is displaying, it will arrange and then it will be printed onto the screen. Okay, and here also we are performing two major operation. The number one operation is your insertion, and how many elements we are inserting? So total 1 2 3 4. Okay, 4 elements we are inserting, and the second operation is your deletion operation. And how many elements we have to delete? So total 3 elements, 1 2 3. Okay, for this we need to discuss the actual program. So just navigate towards the actual program. Yes, the actual program is this one, and while we are writing, always we need to start from a header file. And how many header file we are including? Number 1 and number 2, that is the common, that is the major requirements we have. The first one is, as you already know, stdio.h, standard input output dot header file. And your second header file is, the standard library is which one? The stdlib, the standard library dot header file. And followed by, before following or before performing any of the operation, we need to create the structure of a linked list. And as you already know, within the linked list, it is made up of several nodes, and within every node it is made up of two fields. Okay, the first field is a data field, the second field is your link field, or else the next field. Okay, for that architecture we need to create this kind of structure by using the struct keyword. So after the struct keyword, the structure name is node. Okay, that is the structure name. Within the block, the first declaration is our data as a first field. And what is its type? Its type is of integer. For that we are using the keyword as int. Okay, as the first. And next, struct followed by the node. Within the node we are using in the format of the pointer concept. And this star refers to what? The asterisk operator. Okay, whenever we want the actual value of the node, at that time we will use like that. Okay, but what is the variable we are declaring in such a kind, in such a type? So the variable name is of next. Okay, next, or else it is referred as a link node within your linked list. Okay, it represents the address of a specific linked list nodes. Okay, always it stores the address of your next available node. Okay, for that representation you need what? The two fields, that is the first one is data field, the next one is itself the next field within the single node of your linked list. Okay, next, always the order of execution will start from a main function. Okay, so that we have to navigate towards that part of the program. Yes, so This is our main gateway of the program as a main function. And what is its return type? Its return type is the int. Okay, within the block, we have to make a certain declaration as a requirement. And what is our requirement? That is struct as a keyword. And what is the structure name we have given already? So that is the name as node. Okay, for that representation, for that pointing of a specific object, we are using a asterisk symbol. Okay, and followed by what? The new variable name, that is a head. Okay, always your first element will start from header section, and followed by that the last it will be referred as a tag. In between any number of intermediary nodes within the single linked list. Okay, and by initial, within the starting point, we are representing, initializing the header part as a null. Since we have created just now, there is no any value inserted at. Okay, because later we will do that operation. Okay, for that we have to call certain number of methods based on our number of insertion operation has to be done for every element. Okay, for that we are giving a name as what? Insert order. That is the method name we are giving, but we are calling within the main function, and it is accepting two parameters, and the first parameters are ampersand head. Okay, ampersand is also referred as a address of operator because it holds the address of particular variable, and that variable name is your head. Okay, and followed by the second parameter as a argument, the actual value you are giving is, the first one is 61, that the first element is to be inserted, the second variable is 16, the third is your 8, and the fourth variable value will be inserted as a 27. Okay, for this and all the method call, the pointer, the indicator, the controller, the handler had to navigate towards the actual declaration of this method. Okay, so we have to navigate to that part. This is our actual declaration of the method. The method name is insert order, and it is accepting the return type of void. Void means nothing, that is the null. Okay, it is not returning any of the value. Okay, for that we are using a void kind of return type, and it is also, this method is also accepting a 1 2 two number of parameters. Okay, one is for head and another is for its value. Okay, and followed by, before inserting any of the element, we have to create a space. Okay, for that creation we will use one of these special function. That function name is malloc. Okay, malloc means M refers to a memory, ALLOC refers to a allocation, and that will be depended on number of bytes acquired by the specific data type of a value. Okay, that will be differentiated based on the value or else based on the data type we will use. Okay, within this, the struct node, okay, followed by the new node which is we are inserting now, it should be equal to a struct nodes, because for that we are creating the space by using malloc, and that will be dependent on what? The size of operator. Okay, size of operator is a unary operator. Okay, it will define number of elements present within the specific data structure. Okay, based on that it will multiply along with the number of bytes acquired by the data type. Okay, based on that it will create the a structure or as the blocks of a memory. After creating a space, it's time to input a value within the data field of a that new node as a first field, and its next field will be decided as a null because it is just introduced now. Okay, for that its next field, the address field should be represented with the null. Okay, that is the basic operation we are performing. And to insert any of the value, we have two cases. Okay, first case is insertion operation will be done at a header, that is a head section. And second case, the insertion operation will be done at the intermediary position of your linked list. Okay, now let us discuss the first case. Case number 1, the insertion operation is performing within the header part, the starting point, the beginning end. Okay, within that we have several, the set of conditions has to be satisfied before inserting that value. Okay, for that we are dependent upon one of the conditional statement, that is if condition. Okay, and how many conditions we are applying? First condition and second condition. Okay, total you are applying two conditions. The first condition is just to check whether your linked list is empty or not, that is a null or not. Okay, for that verification we are using the first condition. And second condition is if there is a certain elements present. Okay, based on that we need to compare whether our inserting element is greater than the value or not. Okay, because based on that comparison itself, your ordering, your sorting operation will be done while it is displaying, while it is printing onto the screen. Okay, so the second part of condition is what? Whatever the value which is already present within the header section as a normal data, if it is greater than or equal to of the inserting value. If both or else either the condition become true, because we are applying a or kind of logical operation. Based on that, any one condition can be true. Okay, to become or else to get inside the block of the if condition. And within the block, according to the case number 1, what we are doing? So we are just within the new node of its next, that address field, we are considering it as a head part. It means what? Whatever the new node, new element we are inserting, it should point to the header section. That is the logic. And within the next line, what we are doing? We are just as a header point, we are just pointing to the new node, vice versa. Okay, because if there is a element which is smaller than the value, based on that it has to segregate. Okay, for that it is essential as a logic, whatever we include as a new node. Okay, this kind of updation we have to do. Okay, let us move towards case number 2. Yes, and our second case is inserting the element within the or else in the part of intermediary position of your linked list. For that, the searching has to be done. Okay, to locate at the specific point. At that point, we can introduce our new node. Okay, for that, we need to follow some of the criteria, and that criteria will start from a current. Okay, current works as a temporary pointer. Okay, just to traverse, we are using a iterative variable. That variable name is the current. And where is that current pointer is located now? It is in the place of wherever the head, that is the starting, the beginning point part is. Okay, so because from the initial point we can start our traversal in the search of that specific point. Okay, at that point we can insert our specific element. Okay, that is the logic of declaring our current pointer. and after that we are dependent on while. Why we are dependent on while kind of loop structure? Number one, whenever we are dependent on traversal operation, at that time we need to use any kind of looping construct. Okay, that is the first reason. And the second reason is whenever the range is unknown, whenever we don't know the values, the range, at that time we will use a while kind of looping construct. Within that, it is dependent on two conditions. Okay, as long as these two conditions are valid, that is true, okay, that much number of time it can accept the controller handler inside the block. Okay, whenever it gets false, it will just skip, it will just exit, it will just terminate outside the block of while loop. Okay, within that the first condition is what? Current, that is a temporary pointer of that next, that is the addressing point, is not null. Okay, is not null means there is a actual element exist so that we can traverse to the next element. That is the first condition. And the next condition is the current. Again, the current of next, that is the next element's data is lesser than the specific value, the current value. Okay, current value is lesser than the next value which is we are visiting now. Okay, that should be a lesser than the next value. Okay, if it is true, then only it will accept the pointer inside, because we are applying a and kind of logical operation. According to this, both the condition has to be valid, has to be true. Okay, then only we will get the get pass to inside the body of the while loop. Inside the body of that, what we are doing, we are just traversing with the help of current is equal to current of next. Okay, from the current position we are moving towards current's next position, further forward direction. Okay, how long it can be valid? Until we get the specific point according to these conditions. Okay, if not, okay, it will come towards these kind of two lines of logic. Okay, according to this logic, new nodes next, the link field is equal to current of next, it is moving towards next one. Okay, by following the address of the new node. Okay, and next line, the current of next is equal to new node. Okay, again the current is moving towards the forward direction of the specific point, because at that end we have to insert the current element. Okay, the required element. Okay, till that it will be iterated, okay, for all the available elements. Okay, after overall the operation, with this acknowledgement we can display those inserted elements. Okay, for that we are using a printf statement. Okay, list after inserting percentage d, that is a value. Okay, after that we can execute our method, that is a display list followed by whatever the element present at the head, that is the beginning. Okay, one by one it can display onto the screen. Okay, within not a single instance. Okay, at that time we need to flow towards, navigate towards actual declaration of a display list named method. After any kind of updation has been done, every time we can display using this actual method, and that method name is display list, and it is accepting only one parameter, that is head. Okay, and that head is available in a specific node, okay, of a structure. Okay, and within that we are dependent on a if kind of conditional statement, because before displaying any kind of element within that, within the data structure, minimum at least element has to be existed. For that verification, For that checkpoint, we are using this one. If in case the header section itself a null, it means there is no any element remains, exists, or else presents. At that time, we can print the acknowledgement as a list is empty, and we can return back to the console with this output. If not, if there is a certain element present, okay, at that time we can start our traversal. Okay, we need to visit every element one by one after the other. Okay, for that again we need to define our current named pointer. Okay, wherever the pointer in the current node, that has to be printed onto the screen. After that, the same current pointer has to move forward direction until and unless every element is printed onto the screen. Okay, so that we are using the current. And where is the current now? It is in the place of wherever the head, that is the starting, initial position, beginning, end. Okay, and followed by, to traverse, we are applying a while loop because we doesn't know the range yet. Okay, and current is not equal to null. How long it can be valid? Until there is a not null. Not null means there is a actual value present. Till that it can be a valid. Okay, and if it is a valid, how we can format our output to display? So with the help of printf, we can input. Okay, inputted value can be displayed like a percentage %d. We are using one of the format specifier. Okay, and it will be decided based on the current of the data. Whatever the current element is there, that will be substituted within this position. Only the element is enough. Okay, and if the current element is displayed, next we need to move that current pointer to the next position. For that operation, again the current is equal to current of next. Okay, how long it will be iterated? Until every element is visited, and every element visited is to be printed. Okay, one by one. For every element, we can specify the /n escape sequence character, that n refers to a new line or else next line. This is how we can print all the elements one by one. Dear students, till now we have done with the inserting element as well as displaying the same. Okay, it's time to discuss about our second operation, that is deleting a specific node. Okay, that is a delinking, or else removing, releasing, or else a free up. Okay, operation. Within that, we have to call the related relevant method, and that method name is what? Delete node. And it is accepting two parameters. One is the address of head, okay, and followed by the specific, okay, element itself. The first element we are deleting is 8, the second is 61, and the third one is 27. Okay, to do so, we have to navigate towards the actual declaration of a delete node method. Okay, let us move on to that part. Now we are following the delete operation with this actual method call, and it is accepting only the two parameters. One is with head, okay, and another with the actual value. Okay, within these place the actual values will be substituted here. According to that, the mechanism will be executed based on the logic. Okay, and within that, before deleting, we have to check whether there is a element presence or not. Okay, that is the condition of underflow before deleting. Okay, we are just checking whether the lists are empty or not. Okay, if it is empty, the deletion operation fails. Okay, for that verification, we are doing if header section itself equal to the null. It means what? We can acknowledge, we can format our output as a list is empty. So cannot delete the percentage d, that is the current value. Okay, or else we can also specify it as a underflow. Okay, we can't proceed further, and we can return on to the console with this kind of acknowledgement statement. And if there is a certain element present, at that time we have again two cases, okay, to delete a specific element. Okay, well, the one is if the element is present within the header section itself, and the second case is if the element is present in between the or as intermediary position of your linked list. Okay, let us discuss the first case. Okay, the first case is to check the element within the header has to be deleted. Okay, for that we need to follow these condition, and that condition will start from if the head of the data, okay, head of the data means what, the first node's data field, and that data itself our matching value. Okay, because we got the element within a single attempt, within a single instance. At that time, what all the logic we will execute, okay, by using one of the temporary pointer. Okay, and that temporary pointer is your temp itself, and it is also a based on the node, because it is also a traversable iterative element or else variable. Okay, what it will be visited, it will visit the nodes within the structure itself. And currently where is that temporary pointer, wherever the head is. Okay, it means temp is at the starting position, you are initializing its position. Okay, and after that if the head is equal to header of next. Okay, because if we want to delete the header element, before that we have to do certain updation. Okay, updation as what, we need to update the second element as the head, because the first element we are deleting now. Before that, the head has to be substituted as a next, that is a second element, so that we are assigning as a head. Okay, after that updation we can delete that temp. Okay, wherever the temp is, because we are just extended the position of the header, not the temp, because the temp is still at the position of the first element. Okay, we have just updated the header section with the second element, so that the temp element as the first node we can release, we can delink now. Okay, after that we can achieve the case number 1. Okay, if your element is identified in between, so that we can execute the else part as the case number 2. For that we also call it as find and delete part. Okay, let's move on to that part. This is our second case. Within that, to search a specific element, again we have to traverse. To traverse we are using the while. Okay, and within that we are using one of the common pointer, that pointer name is current. Okay, for that current variable declaration we are using this line. Okay, that current is of type node of a struct, and it is initializing in the place of a head. That means at the starting point again, because whenever we are traversing we need to start from the scratch, from the starting point. Okay, and if the current of next, that is the first node's next field, the link field is not at all null, it means there is a actual value. Okay, that is the first condition. And our second condition is current of next of data, whatever the data present within that node, if it is not equal to our expected value, because we are doing find and delete, so that how long it can be iterated. okay, repeated until we get our specific required matching value. If it is not matching, it will be iterated again and again. If we get the element, the while loop will be terminated, because within that point we can delete, we can delink, remove the element, okay, because we are applying again the AND operation. Okay, according to this, the both the condition has to be satisfied. Okay, first what we are checking, we are just checking the existence of the element, presence of the element. Within the second condition, we are using the whether our element is matching with okay, the current value or not. Okay, based on that it will be decided. Okay, for every time your current should be forwarded to the next node by using current is equal to current of next. Okay, how long? Till we get a specific value. At that point we can perform the deletion operation as the second case. And further we will discuss about what we can do if the element itself not present within our entire linked list, so that we have to move forward to that part. Okay, this is the other case. So the other case means whenever you are not getting our element within the entire list of singly linked list, at that time we can check with this condition. Okay, that condition will be followed. Current of next is equal to null. It means there is no any element available at all, and still we have not matched with our expected value. By that time we can print our acknowledgement statement, and that acknowledgement statement we can format like element percentage d, whatever we are looking for, that is not found in the list. Okay, and that value will be reflected or substituted here. Okay, and if not means if we get the element after, in the case of 1 or else 2, okay, we can follow these three major lines as a logic. Okay, within the first point, first line, what we are doing is we are again initializing the temp. Okay, temp as a temporary pointer is equal to wherever the current of a next, because initially temp as well as the current will be in the same place. Okay, but while we are deleting, the temp will be holded on to the current place, but what the current will do, the current will move towards the next place. Okay, within that place what it will do, it will be shifted or else skipped as a specific element which is matching. Why it is skipping? Just to delink, just to delete. Okay, for that we have to make necessary updation, because wherever the temp and its next, the link field will be updated with the currents next of next. Okay, currents link field and its link field's address we have to update wherever the current of next is. Okay, by that time we can update before deletion operation just to connect each other after delinking the current element, the specific element. Okay, at that time free wherever the temp is, that we can free up, that we can release permanently. After doing this and all the operation for every element, if we want to display the updated linked list, we can format like this: list after deleting the specific element. Okay, at that time again we can utilize the same method, that is display list. Okay, whatever the element is present, it will display. Okay, not in the same of a randomized order how we insert at the beginning, but instead of that it will arrange first. Okay, and then it will be displayed onto the screen. Okay, this is all about the program number 7. Now let us look on to the actual output, and within the output what we are doing, list after inserting 61, the only element present within the linked list, and next after the 61 we have inputted the 16. Okay, but after inputting any kind of element, okay, it will be in the sorted order while it is displaying. Okay, and next we are inserting our third element, that is as a 8. Again it will be displayed as a in a ascending order, ordered format, the sorted format. And next the fourth element is 27. Okay, but while it is displaying, it is in the third position because it is in the ordered format. Okay, after inserting 4 elements, it's time to delete the 3 elements, and those 3 elements are 8, 61, 27 from the linked list. Okay, this is the transparent way of reflecting your output for 2 operations, insertion as well as deletion. I hope you all have understood today's concept. If you find topics interesting, do like, share, and if you have any of the questions, just comment me below. Thank you.